So we are 4 speakers here today. We're going to talk. We have been talking about AI here these past days, and the aim is to talk about AI internally for the good, for the bad, for the ugly, for everything. So we'll try to give you examples of how AI can be used for good purposes in journalism. We'll try to show you how to deal with cases that AI is used for bad purposes, for manipulations, for deceiving people in journalism again, and what we can do about it, looking at cases in image, video, and audio. And we're going to show you also some tools that you are going to be able to use. Maybe you will find it useful in the day-to-day practices. So we aim to give you also access to those so that you can experiment on your own. So we can start with Professor Andreas Veglis. Professor Andreas Veglis from the Department of Journalism in the Aristotle University of Thessaloniki. Andreas is going to talk about AI and how it can be used in journalism for purposes, and then we will continue with the rest of the application. So, Andrea, the floor is yours. You can unmute and you can share your screen. Start presenting.
Okay, thank you, Nikos. You can hear me.
Let us raise the volume a little bit. Yes, we can hear you.
Yeah. Okay, thank you very much. Unfortunately, I wasn't able to be in person with you due to a certain illness. So my introduction is going to be on AI in journalism. Here you can see a ChatGPT generated picture with DALE. When I told it that I want to make a presentation on AI in journalism, it created something like that. But of course, it is worth mentioning that journalism and technology were always associated close to each other. Don't forget from where we are coming, from print editions to radio to television, and of course, with the introduction of internet and its services, and of course, the social networking services. In general, technology changes from time to time the way media content is produced, distributed, and also consumed. Already, AI tools are employed in media organizations. Let's discuss a little bit about some indicative examples. Washington Post used data mining to create tip sheets during the 2020 US elections. The company Gannett, the project Localizer, uses this automated content production to create local content for 230 newsrooms. Techniques such as title testing, which use machine learning to identify the best performing title from a set of titles, have proven effective in improving click-through rates for publishers. And also New York Times employs AI in order to try to convince with automatic text its subscribers, its registered users, but without a paid subscription, to become paid subscribers in order to have access to more content. Now, in general, the areas where AI can be useful in journalism can be categorized in 2 areas: data and news collection and news production. And let's see some examples, some example of processes where we can use AI for content discovery, for tagging and collecting content on social media, quotes from news reporters, content from governmental websites. And it can be used for content discovery from structured data and also from unstructured data. Especially in the case of unstructured data, this is more useful with the help of ChatGPT, which is very useful, very efficient in extracting data from unstructured data, but of course, with all the problems that everybody knows, hallucinations, making up things that don't exist. So we need always to evaluate the accuracy of each specific process that we use in content discovery before using it for publishing content. Document analysis is another area that can be used, especially for cases like where in the case of investigative journalism, where we have to edit large sets of public records combined with text summaries, categorize and highlight documents of interest, summarize documents so they can be quickly scanned by journalists for relevance. In some cases, the documents are not in digital form, so we need to make them in digital forms with some kind of OCRs, of OCR programs. And we haven't tested yet how ChatGPT can deal with problems, with mistakes that appear from the OCR programs. So this is an area that is worth investigating. For example, here you can see ChatGPT. This is one of the examples that I present to my students when we discuss about the use of AI in journalism. Here I provide ChatGPT with a document, a PDF file, and of course it can produce the basic findings. I ask him in Greek, so it produced the basic findings in English, and then when I ask him to make the translation, it can also provide the translation to the Greek language. About the translation, we are going to discuss a little bit later about this issue. Also, it can analyze various files. For example, I asked ChatGPT to analyze the presentation that I am showing you today, and it made a description, so I'm able to see more or less what it is included in the presentation without actually reading the entire presentation. So, moving to the translation, ChatGPT and generative AI is especially useful where we have documents that include many different languages. If we want to check the efficiency of translation tools, the dedicated translation tools are more efficient than ChatGPT. But ChatGPT is very efficient when we have a mixed kind of languages and we want to get a rough translation in order to scan it and evaluate to see if we can find the things that interest us. Social media content creation. Generated AI can be used for creating content and schedule optimized posts for Twitter, Facebook, Instagram, cropping photos and videos for different formats. Of course, we don't, the specialists do not recommend fully automated the process because always we need a journalist to oversee the whole process and check to see if something is wrong before making the publication. And of course, in many cases, as you all know, the specific prompts, for example, in ChatGPT that we are entered, can make an important difference on the content that we are getting. Now, as far as automated authoring is concerned, we can distinguish between two cases. First, we have the automated authoring from structured data, for example, sports, weather, natural events, and anything else offered in a structured form. That means in a table. Automatic authoring based on structured data is well known, and it is documented under the name algorithmic journalism in the last decade, and it is mainly based on templates. Of course, ChatGPT can produce more fluent content, more fluent text, but always the generated text must be evaluated for accuracy before publishing. This is very important always to remember. In the case of non-structured data, for example, obituaries, short press releases, previews, or events, ChatGPT is very efficient, and this is an area where the previous decade tools that were based on templates-driven automation it wasn't, they weren't efficient. So we can use ChatGPT and generative AI in general in order to extract data such as dates, times, location, and short description. And we can use the structured data in order to produce more content. But of course, the problem here is that we don't know if generative AI will find all the necessary information, all the important information. And this is something that we must always have in mind. Newsletters, we can personalize newsletters and optimize for delivery time. We can tailor the newsletter specific to the needs of each individual based on a model that we may have for the interest of each individual. It can rewrite, ChatGPT can rewrite headlines and summaries. So in order to make more appeal based on the interest of each individual, and focus more on the aspects that are attractive to each individual. Text summarization, again, is a very useful tool. I won't mention many details, but in general, the main point that we need to focus on is that is the particular content, what is the tolerance of faults in any particular content? Because in many cases, there are other factors that can influence the automatic summarization that generative AI will produce. Comment moderation, here the things are different depending on what kind of moderation we need to do. For example, if we want to search mainly for hate speech or some offensive words, this is quite easy. But if we want to make more let's quality moderation, things can become very complicated. And of course, content transformation and reuse from structured data, we can produce content for different platforms. For example, taking an article and creating a title and keywords to post on social media. And also it can be used, already it is being used for search engine optimizations. Many SEO specialists are using such tools and can improve significantly the success of this process. Of course, always with the supervision of a journalist. And finally, push alert personalization. Again, we can personalize the content for each individual. And here I will stop, and I will give the floor to the next speaker, and I will make some other comments at the end of the panel. Thank you. Μικρόφωνο, Μπάμπη.
Can you hear me now? Okay. Thank you, Nikos, for the introduction. As Nikos said, I'm a professor at the School of Journalism and Mass Communication. I'm originated, scientifically from the School of Electrical Computer Engineering, so my background and my field of expertise in media technology. However, in our department, we have also worries in studying and analyzing how technology is perceived by the media users, not by the non-technologists, if you prefer. So on the left, we can see a snapshot of our paper to gave this stimulus for today's presentation. And of course, on the right is an open call of a special issue concerning the use of AI and aspects about technology ethics and literacy. What we see on the left is an effort we conducted to evaluate how journalists and broadly users, let's say, in the role of citizen journalism, can understand how images are tampered and if they are able to utilize some digital image forensics algorithms to understand what part of the image has been altered and can be part of misinformation or disinformation effort. So the problem exists for many, many decades. We can see here that tampered images exist in the past. Today we have the deep fakes with the elaboration of artificial intelligence of generative networks, let's say, and we can have also content that is produced directly by computers. In many, many aspects, you know better than me that visual documents have been used to support as evidence of the news scene that the event that's presented in a news article actually happened. However, as technology elaborates, many users try to tamper, to falsify this document in order to tell a different story. So we need to have skills to understand and to detect when tampering effort is made. And in this perspective, here our researchers in CERTH have developed a tool set with various algorithms on digital image forensics, trying to visualize inconsistencies in order to be able to understand whether there's a possibility to have some tampering actions. Unfortunately, it's not such easy for the common users and the journalists to understand how these algorithms actually operate in order to be able to interpret the result. However, as we will see later on, nowadays, generative AI gives us new opportunities to summarize the results and provide, as we say, probability maps, indicating the spots in which can have tampering actions. In all cases, this is not an easy task because as technology propagates and elaborates and advances, not only forensic technology elaborates, but also counter forensic, which is the technology to conceal the tampering traits, let's say. Okay, so we need to keep up with technology evolution, and in all cases, at least in my view, an information provided by a machine saying that this is authentic images with a possibility of 80% is not adequate. We need to train the users to be able to evaluate the results and to have their own opinion. So in all cases, we have needs of media literacy. So I will proceed. This is pretty much an overview of how these algorithms actually operate in very quick analysis. They are trying to find inconsistencies concerning the content, the center, for instance, if different noise footprints are presented in different parts of the image. This means that someone took a part of another image and embedded in the new one. Or in physics, they are trying to evaluate physics. If we observe some inconsistencies concerning sunlight and rays of sun, this means that we have probably a forgery attack. And of course, one very common approach is to check the format. If I have one image compressed in one format with a specific quality, and then I'm trying to create a forgery, a tampering version of that image, taking content, someone opened the microphone, and we have iPhone. Okay. So if I try to do that, taking part of an image and importing in another image, if these two images have different compression configuration, this can be visible through this algorithm. So this is the tool that we used. It's a research that started around 2017, and we had some delays due to the COVID situation, and we were able to publish our research in 2020. So this is the environment of the image verification assistant. It was part of the review project that was conducted here in CERTH, coordinated by CERTH. And this is the layout, the front end of the website they used to have. This has been altered. Now, as you will see it later. And these are some of the main tools, main algorithms here on the left that are used to detect forgeries. Each algorithm provides a color map, a heat map, as it is said, and we need to be able to understand, because they do not represent the same kind of story. They represent different aspects, so we need to know what actually each algorithm visualizes. So we tried to create some images. We selected some real images, which is not encountered every day, images that can be believed by the audience that they are fake, like the images we can see on the top here. We also collected some images that were already tampered, and we also conducted our own effort to tamper some images through object detection, removal, insertion, and so on. So the diagram on the right shows the procedure we followed. Actually, there were two tests. In the first one, a small number of users, if I remember well, was about 10. 5 were called as media experts, and 5 as algorithmic/computing experts. They were about to check some images physically first with physical inspection, and then they were also subject to visualize, to analyze the heat maps provided by the digital image forensic algorithms. And in between the two stages, there were some tutoring, let's say, some training, how these algorithms operate, and the process was repeated to see if they understand something better, and they provide different results. So here we can see for some of the images that in general, both image experts with orange and media experts with yellow, let's say dark yellow, and overall is the green bar. We had some improvements from time 1 to time 2. In time 1, they had not instructed how these algorithms operate. In time 2, they were instructed. But as we can see, this is also content dependent, because in some cases it was not such easy. So in Iran authentic image, the use of the algorithms resulted in different in the opposite direction. We had that the correct the performance was decreased, the performance by the humans, I mean. So what I'm trying to say is not such an easy task to claim that to say that using these algorithms you will have better authentication results. So here we have a little bit more elaborated image in which still we can see time 1 and time 2, which is the instance before the training and after the training, after the presentation of the algorithm, because this specific test was conducted online with many more participants. We also asked them to vote to select the confidence, their level of confidence. What do they think if this is original or tampered, and also to vote for the difficulty of its sending. If we have some questions, we can see the results later, because still the important conclusion here is that still we do not have a linear behavior, meaning that after using algorithm we have better results. So it's not linear, it's kind of complicated. So it means that we need to emphasize a little bit on the right use of the algorithms, especially for different kinds of content. So let's come to today. This is the new print screen of the associated service. And we can see in the top here that we have 4 fusion models. Are models taking as inputs the heat maps of each algorithm and provide probability maps saying us where it is possible to have forgery. The first probability map, which is this one, the first fusion outcome, found exactly the spot in which the forgery attack was deployed. We have 2 objects here. The second one is a clone of the first, but still we can see that, let's say, cannot see, because it's a little bit small, but okay, I will tell you. The third fusion map says that the probability of forgery is 2%, which is not correct. So what I'm trying to say is we cannot teach journalists and generally average users to rely entirely on the recommendation of the algorithm. So in these cases, we need to be able to understand how these algorithms operate, or this is the case in which the so-called transparent and interpretable AI would provide some new insights. I mean that transparent AI is the situation in which data and code of the algorithms are available, so if someone can repeat the experiment, it has this ability to repeat the experiment. But interpretable AI means that we have to provide the patches, the part of the images that are processed through the neural network, indicating that we decided this 74% of possible forgery because this patch looks that way. And of course, we can still combine outputs of these fusion models to train new networks without bothering users to check which method should I use depending on the problem that I check, if it is a clone object or if it is a background Google or whatever. But still, we can provide something that users also understand how this works. For instance, in the era of large language models, an output of the algorithm could be to extract a documentation, a text documentation, which I think could be easily implemented by providing the right prompts to ChatGPT or similar utilities, saying that this question was decided to be, this image was decided to be non-authentic because of that and that and that. So it is important to provide such kind of insights to the end users, and for sure, media literacy needs are always needed. Here, quickly, I suppose Nikos will present some of these tools. We see how these tools are presented in the MedDMO hub, which is the Mediterranean Digital Media Observatory, and in the associated MAM environment of the MIVER project, that contain elaborated versions of the algorithms used before. And some quick thoughts. There are some tools trying to complete this fact-checking through the basic principle of 5 ways of generating what, who, when, where, and why. They provide weather information like the Alpha Cronbach. I can put the day and the exact date and time an event actually happened, and to provide what was the weather, what was the sun, the direction of the sun rays. So if I see an image, I can still understand if this image is stubborn or not. But in the era of generative AI, this can become more effective by produce a 3D model in which we can navigate and see how the image, the shown image is, and how we could actually see in that case. I will finalize my presentation and pass the floor to Nikos with an audio example. Here we have two examples of audio segments, and each one of them has two visualizations. The first, the green one is the waveform view, how the audio signal alters over time, and the other is the spectrographic view, which concatenates time information, the horizontal axis, frequency information, the vertical axis, and color code to see which parts are more dense. So, can you tell anyone from here if this sounds as we can inspect them visually are tabbed or not? Trying to say it is another task, perhaps more difficult task, but for sure.
How do you know?
For instance, I could say that here we have a discontinuity, which means that someone spliced and copied back to different segments. But still, I suppose this is part of the journalistic job. If I have 1 hour duration recording, it's fair to sort it by making the edit. Okay, so it's still trivial. Now, the audio we will hear is in Greek language. I suppose many of you cannot understand, but this was a conscious choice because without getting the message, I want to know if you understand if this is part of editing or not, or what. So let's hear the first one.
Συντρόφισσες και σύντροφοι, καλησπέρα. Να είστε καλά. Σήμερα αρχίζει το δεύτερο συνέδριο του κόμματός μας. Μια πολύ ωραία φθινοπορεινή μέρα. Έχουμε περάσει πολλούς χειμώνες και θα συζητήσουμε και θα αποφασίσουμε για την άνοιξη της χώρας μας.
So, any idea from those that they don't comprehend the language first? What do you... Come again? No, the language is Greek, but I'm not asking that. I'm asking if you do not understand the language, can you tell me if you think this is edited or not?
There seems to be a change in the background noise.
Yeah, there is a change in the background noise. However, such change in the background noise can be caused by the sound system in the room. It's not something that necessarily implies that a tabbering effort was made there. And as I said before, it can be parts of different.
Is it recorded by one device, though?
No, to be honest, I do not know because I downloaded this this audio from a satirical Greek show. It's for sure.
My Greek is a bit rusty, so.
It's for sure edited, but it's not an easy thing to understand if it is intentionally edited. Here we have a politician discussing in a conference, debating in a conference, saying that using a metaphor, we were in the autumn, in the winter, and we will become go in the summer of a political party. So someone thinks that, okay, it's a joke. It's not possible to have all these 3 weather seasons in one sentence. So, but we cannot tell for sure. The evidence here are not for sure. The other example that I will show you, I asked one of the people who is good in audio editing, and I told her, it was a colleague of mine, please pay attention and tell me what do you think. And she told me it's authentic. And then I repeated, did you hear what he said? No, okay, let's hear it again. And then, oh no, it's not authentic. No, let's hear it and I will comment on that.
Για να οικοδομήσουμε παράλληλα με το πρόγραμμα ένα σχέδιο που θέλει την ανάπτυξη πάνω στα συντρίμμια της κοινωνίας και της εργασίας.
What do you think? So technically, it's very good.
Synthesized?
No, we have 2 different political speeches and we joined them. Not synthesized. Yeah, it was live and then joined. It was a former Prime Minister of Greece. In the first part says that we will develop our economy. And in the second part says, in the rules of our society. Okay, so it's not possible to say that, but I'm saying that we are someone that understands Greek, and she said to me, no, it's authentic. And then I asked, did you hear what he said? We played again, oh, it's not authentic, because what I'm trying to say, it's kind of tricky.
But that's a shallow thing then. Just editing, basically.
Yeah,
Yeah.
it's not. Yeah, yeah. It's a kind of editing. Yeah.
Because I'm strange.
Yeah.
Is it? You tell me this. I have no way to say that what's on the right actually is clearing of what's on the left. So I don't know. I don't know if what you're showing me, what you have here is actually something that has been verified on the left, or actually this has been something completely different. So can from the grid, speaking interestingly, you can clear enough to catch the fact that okay, it's
Yes, but
it's the same on the left and the right. What is interesting? It's the same.
I suppose that is speech taken from two different occasions or two different time slots. In the first, it says that me as a prime minister, I will develop the economy, and in the second, says that by this.
The question is not on this. The question is how are you sure that what this is actually the clean version of it?
It's not the clean version, it's a different version.
Yeah, I don't think it's what I'm
You cannot. What I'm trying to say is that it's difficult to tell. Okay, there are, yeah, this is what I'm saying, that of course you can understand which is important, but here we have some slices, so you can tell this is an edited clip. Someone put one segment and put it next to another segment. So we are cautious that might be something here. Okay, that's it. Okay, so what I'm trying to say is that even the best algorithm, you still have to be aware of what might happen. Okay, so I will pass the floor to Nikos, who will continue with audio examples.
Nikos is a postdoctoral researcher in the same laboratory. His research is in audio authentication techniques. We focus on this.
Okay, thank you very much. Thank you for the introduction. I haven't written more of my affiliation, but I'm in the same laboratory. So in this presentation, we will focus a little more on audio authentication, how to detect using AI-fueled, let's say, automations, how to detect if an audio file is tampered or not. So we'll talk about what is audio tampering. We'll go a little faster on that because we have already analyzed a little. What is an editing artifact? What are the main techniques for identifying such artifacts? We will decide which is the best technique of all. And then we will present a framework for audio authentication. And we will pose the challenges for future work and research on the domain. So, audio tampering refers to the malicious editing of an audio file to alter the meaning. So in this way, tampering for journalistic purposes to make something shorter can be considered as editing, but it's not malicious editing. It has to have some goal of alteration of the meaning and for disinformation and things like that. There are several different occasions of doing this. One is the audio splicing when you insert an audio segment from a completely audio file. So I'm saying something and you take another recording from me. You take one word, put it in my original recording, and you alter the meaning. There is also the possibility of just removing a segment of what I'm saying. So this alters the meaning. And there is the possibility of taking something that I said and putting in another position, and this alters the meaning. So I have created some recordings. They are in almost English because I'm talking.
Hello, I am Nikos, and I am very happy to be with you today. I am not at all bored of presenting.
So this is the original recording of how I'm feeling about being here on this sunny day. And there is a tampered version of it that I edited myself.
Hello, I am Nikos, and I am not at all happy to be with you today.
So somebody, for malicious purposes, might take my declaration of happiness of being here and alter the meaning so that it seems that I didn't want to come here. And this isn't the case where just take a segment from the same audio file and
Hello, I am.
so how to detect such positions of tampering? There is, as Mr. Dimoulas said, this causes must cause some discontinuity in the audio file, the audio stream. This can be seen sometimes in the visualization. This can be heard, and in any way, we're trying to find more visualization, more tools to make this understandable by human. So, in the case we have different files, there are different recording attributes. When we have a recording, it has several specifications. These specifications, they concern the encoding, as we say, MP3, waveforms, AEC, and stuff like that. It concerns the room acoustic parameters, where it was recorded. It concerns the background noise. As we said before, anything that is in the background, even hearing, will all stay silent. We will hear that there is some sounds in the room, some things like the air conditioning or the projector or anything. And there is also a very popular method of checking the electronic network frequency discontinuity. I passed it really fast, but we will go to each one of them separately. So, different encoding. Encoding mismatch comes because when we use different files, it is more than it's very, very highly possible that these files have different encoding history. Encoding is the loss compression of audio files using perception models and psychoacoustical models, etc. And there are many algorithms, many formats of encoding, and each encoding format has lots of configuration of how much will be compressed, what kind of let's say, technique will be used, and stuff like that. So it's highly possible that even if we take 23s, it's very possible that these 23s will have something indifferent. And in many ways, this is something we can understand. Also, sometimes, because this is a long compression, when you compress something, and you make it lossy, if you take, for example, a good quality recording, and you create an MP3, and then if you encode it back to a lossless format, let's say, the information that has been lost cannot be regained. What is lost once is lost. This is why we're talking about encoding history. This means that we don't care about the extension of the audio file, if it says .mp3. We care about what has happened to this file in this history of existence that has caused permanent damage that is being carried in future versions. So, in this case, I will show you the splicing of, it's the same example as before. This is our playground example. And we will see that it's not shown very, very well in the projector. This is the spectrum that, as we said. This is splicing a bad MP3, bad quality MP3, with a lossless waveform. So let's listen to it.
Hello, I am Nikos, and I am not at all happy to be with you today.
The position where the tampering exists, because we know it, is the not at all. It's here. As you can see here, these are the higher frequencies. If we close all the lights and we could see the projector better, we would see that in the MP3, in the splice segment, this is totally black. While here, there is a frequency information. It's not really audible. I believe not at all audible, especially in these conditions.
And I am not at all happy to be with you today. Hello.
Probably we wouldn't say I don't hear any frequencies above 16 kilohertz, but you can see that they don't exist. Again, this is an extreme example of a very hard.
Hello.
This is an example which uses a lossless file and an MP3 of better quality.
Hello, I am Nikos, and I am not at all happy to be with you today.
In this case, it's also not audible, especially in this room right now, and it's also not visible because this MP3 has information in these bands, but of course some of the information has been lost. So this visualization can let us understand an exaggerated example, but does not let us understand an example which is a little more moderate. So when we have a change of encoding, sometimes it is audible and we can say, okay, this is bad. Sometimes it is evident with common visualizations, and sometimes it is not. It cannot be perceived by humans. So this is where we want AI. There are several methods in literature using statistics of the frequency response, using information theory, using deep learning to understand the type of compression in every audio segment. So if we had a model like this, it would tell us that here it has less information, like that. Room acoustics. When we're recording something, we're actually recording the room. So when I'm recording in an anechoic chamber, or when I'm recording in a cathedral or in a bathroom, these are spaces that are very characteristic of how some sources sound in there. So every room has different attributes, and the most classic, let's say, of them, the most easily detectable is what comes about the reverberation. So again, if we take an exaggerated example.
Hello, I am Nikos, and I am not at all happy to be with you today.
So this is an example where the spliced segment has been recorded in a place with lots and lots of reverb, and it sounds unnatural, so we understand it. But if we put something with quite a lot of reverb, but not so exaggerated.
Hello, I am Nikos, and I am not at all happy to be with you today.
My ears, it's quite inaudible. We cannot really understand it. So again, we need AI to help us, and there are many models. As a laboratory, we have research on this, which is called blind room acoustic parameter estimation. There are models that try to understand the characteristics of a space for other reasons, but we use it, we implement it, we integrate it in our system of it within one recording. For some of the segments, we understand the model realizes that it has different room acoustics.
Hello, I am.
Background noise. Again, when you record something on the background. This can be shared or it can be inaudible, because when you have the voice, usually the voice is very dominant. Here I'm recording two silent rooms. They are in my house. One is my, let's say, office, and the other is the kitchen. The kitchen, even though it's quite silent, I was not talking, nobody was talking, everything was closed, but because of the refrigerator or something like that, it has a very different background noise. So it is quite visible that where it changes, where it stops being my room, it starts being my kitchen. If I was speaking on top of it, you would mostly hear my voice, so you could not understand this. So it is, while it is very distinguishable, it is inaudible. In this case, what we propose is voice activity detection. Yes, so you just take the non-voice segments and you analyze those. Electronic network frequency is something. Every electric network has a frequency, this 50 Hz that we say, that is unstable. The electricity companies, they monitor this. So whenever you record this frequency of the network. So it's possible to extract them using deep learning and see if there are discontinuities in this. Also, you can see when a recording was made by matching it with the archives of the electric company archive. So, which technique is the best? As you might have realized by now, we cannot really say. It depends on what kind of editing we have. So, we need all those techniques to create a framework to understand every possible editing. And also, as everybody else has noticed, it is very important to have human intelligence. Because if we had an algorithm saying that the space where you say M is tampered, we all understand that nobody had a reason to tamper that thing and put an M from somewhere else in hello, I am Nikos. So when something says that not at all is maybe tampered, we understand that there is a reason to do this. In our proposed framework, we have a prototype web application that can, where you can upload files or give video files or links. And we have several visualizations that are interactive. You can see when you zoom in one, you zoom in all of them. So you can check places like this peaks and like this thing where it appears to be damaged. And then you can listen to the audio file in the suspicious points of the visualization and make a final decision. Of course, however you do work with this, people will just edit things better. They will add background music, they will add heavy compression, they will add extra reverberation to hide the reverberation mismatches. So these are all challenges for future work to make something that is robust. And also the trend of our days is generative audio models for speech synthesis, where you can just perform acoustic matching to create a recording that matches the voice of someone. This is rising a lot. In Greek, it's working so and so, but we'll find it in front of us the next years, and it's important to include it. It's in our plan to include it also in our framework. So thank you very much.
Question? Yes, thanks, Nikolaos. Very, very interesting. We once did a project in audio forensics, but it's been a while. So I have one specific question. Audio forensics is kind of difficult, and you look at curves and charts and what have you, and few people really understand the details. So is there a way you can enlist AI to make sense of it, like via OCR, and then tell the users, the end users, exactly how file was manipulated?
Yes, this is a very good question, and it is something that we discuss, because in all the visualizations, you try to just show something that seems weird. It's quite the same like the image verification process. Yeah. However, sometimes maybe this is not enough, and in this such sensitive topics, explainability is very important. I believe that if you have a framework like this, a superposition of methods, or an ensemble fusion model, something like this, and it can be combined with an assistant.
With LLBs, as I said, for the image, yes, with the right prompts to tell you not what exactly happened, but possible tampering.
So it's like, look at this curve over here.
Yeah.
This looks really weird. And
at no point we don't want the system to make a decision. We want this to be a hybrid decision-making process, a human in the loop, as they say. So if you have a generative AI that can produce text, they can tell the user, in this visualization, there seems to be a spike. This visualization refers to the encoding. So the user could understand this if they read the documentation, but this is maybe too much to ask for somebody to read the documentation for other visualizations. So this can be an intuitive way to tell them. In the encoding visualization, there seems to be a problem there, and there. In the room acoustics visualization, there seems to be a problem there, and there. So the user can actually go and listen to the spots, the time stamps, and make a decision of how it and why it should be stamped there.
So it's in the making, basically.
It's in the thinking mostly. To be completely honest,
We should go with Nicholas. Yeah.
Is it possible for LLM to see this image, some visualization, and spot what's wrong?
I suppose that we will have some prompts already predefined and direct the LLM to provide the right answers.
for example, now I'm just spitting out of my mind because we haven't started working on this. If you say, I find something here, the user says, maybe click it. And instead of giving them a link to go and read what the visualization is about, you may have an LLM saying, this might indicate holdings and things like that. So just make every time give the exact answers. But we haven't really worked.
Yes, but we haven't started to craft that, but I think we can have a set of rules. And what we can see, what they can see the audio experts to be passed through such a translator, let's say, to make a projection between some findings and possible reasons to be expressed in intuitive language. Yeah,
Yeah, a bit of more general question. And so thanks for the presentations. I think it's very interesting. And I'm by no means an expert, but it just triggers some thought here. Because it strikes me that it's a bit of, let's say, a digital arms race between tampering and protection methods. It's ongoing. But I do not necessarily see a fundamental reason of why eventually it may be just impossible to detect any tampering. So eventually we may end up in a situation that there is image created that you just can't detect, audio you can't detect, and should we not think of a way of prepare audio society for this case? We can't really be sure anymore.
Yeah, because when I was doing my PhD, there was another PhD candidate with Mr. Dimoulas, who was from social sciences more and was in these topics. And what she came, the result of her research was that the tools are very helpful, but it's not something to rely on. It's still important to have people that have a knowledge of how to treat the content, how to, so in the end, when you accept something as true, as valid or anything, it has to do with your own skills of decision making.
Nico, if I have half a minute to
We are already past 10 minutes.
okay, we can discuss it later.
Okay, so we should be ending here, but let's have the last part as well, where I will show you some the handling that we have done in a number of tools that you can also use. When I say we are the media analysis, verification, and retrieval group from CERTH. We have created an environment where we have bundled some of the tools that you have already seen with some that we haven't. It's an environment where you upload an image or a video and it is automatically analyzed, it's automatically tagged, it's automatically classified, and it's ready to be searched and to be discovered. And through this environment, you can also, we can cartoonize content that is inappropriate or that is disturbing. We can cartoonize these content so that we protect the viewer, so that they don't come in front of it without being prepared. We have this image verification assistant that Babis has showed you as well. We have the deepfake detection where you can still get that. And I will show that to you also live. Saying that you can also have access to that. So if you want to try it out for yourself, you can ask for an account on this. And it's very easy to operate. You just upload content from here. And you can upload an item or a number of items through a folder or through a CSV file. Perfect. Also see it here. So you can upload the items from this interface. And then in the assets tab, we can have a look of everything and how it has been analyzed and how it has been automatically tagged. A number of known persons are also automatically recognized. As you see here, all those people who are well known have been automatically recognized. You can also add your own annotations if you like, your manual annotations. And then you can search with everything that has been already identified. So with objects, with actions, you can have free text queries, or you can pick objects and actions from here, or categories. And then if you click on an item, you can examine it in more detail. You can run these forensics algorithms that Vaglis has shown you, and there are a number of algorithms that you see now. This has been executed in real time, so it's quite quick. And by clicking on the I button here, you see a quick and easy way to understand on how those algorithms are operating. You get those heat maps that show you probable manipulations, and if you click on this button, the heat map is superimposed on the image so that you understand where the manipulations are taking place. But as Babis explained, you have to be trained on the algorithms so that you can understand the output better. There is this geolocation which compares with images, with similar images, and shows you a probable place of where this image has been captured. There is the similarity that I told you before, which shows you similar images, visually similar or semantically similar to the one that you are using. It's not the exact duplicate, but you can also click the duplicate and find the, like you do the reverse image search, which you very well know. But as I said, this works also very nicely with videos, which is something that is not out there. You see the cartoonized photographs, which are disturbing images that you are protected from. And so you can search this way as well. And when there is a deep fake, so when there is a video, there is a deep fake analysis under AI generated tab, which shows you two different things. Probability of face swaps and probability of face reenactment. So if a face has been totally swapped, and we only look at faces, so these are the type of deepfakes that we examine, and we break the video in different segments, and for every segment you get a different probability down there. And when there are more than one faces in the screen, in the segment, we show the bounding boxes of the different faces and different probabilities for every different face. And there are also when an image has been synthetically generated, there are different models that are operated here. And again, if you click on the I sign, you see the different model, because there are different techniques of synthetically generating images. So every different model is trying to identify images have been generated with different methods, and it is expected that some will flag it as AI generated, some will flag it as genuine. So you have to see all the different flags, and again, the human has to be in the loop to identify where the manipulations, if there has been a manipulation. did. So this is an environment where you can upload stuff and you can analyze it and you can check it and you can have all your content there. And you can search also for content that you have used in the past. So this is it from us. I hope that this information has been useful. Come in touch with us if you want to test and try out any of our tools and get accounts and trial accounts and see how this work for you. And we'll be happy to hear from you also your ideas on how this could become more useful to the world. Thank you for the attention.